Hi, welcome everyone. My name is Sarah Carr, and I'm coordinator for the Coastal Marine Ecosystem-Based Management Tools Network. This webinar today is also co-sponsored by openchannels.org, and we'd like to welcome everyone today. We're very pleased to have with us today Pasquale Pagano and Gianpaolo Coro, who are with the Italian National Research Council, and they're going to be speaking to us today about the iMarine Data E-Infrastructure Initiative for Fisheries Management and Conservation of Marine Living Resources. And we're very glad they could be with us today. This is after work hours for them. So we're glad they were willing to do it. Before we get started, I just wanted to let everyone know we'd like this to be an interactive webinar, and so there's two ways you can ask questions. There's a virtual hand icon in the user interface. You can raise your virtual hand to be unmuted if you want to ask a question directly to Lino and Gianpaolo, or you can type the question into the question panel in the user interface, and then I'll relay it to the presenters. And so you can go ahead and send questions in at any point during the webinar, and some we may hold till the end, the question and answer period at the end, although some we may address during the presentation itself. But anyway, welcome everyone, and welcome Lino and Gianpaolo. I'll turn it over to you now.
Okay, thanks Sarah. So let me start by presenting ourselves in such a way that also you can figure out, our faces. So I am Pasquale Pagano. I have a master's degree in computer science and a PhD in information engineering on distributed systems. And the other presenter will be Gianpaolo Coro, that instead he has a master's degree in physics and cybernetics and a PhD in computer science. The color that I select for this slide are also, important, because I am only, let me say, the dark side of the iMarine infrastructure, mainly solving, the issue and, delivering solution, while Gianpaolo is more the front end, and he discusses with the community and with the users to solve their problem, and he helps them, in satisfying, their needs. So I will start, presenting the concept. iMarine is the initiative, the group of people that lead the initiative, and iMarine is currently exploiting an infrastructure that is an operational platform that is named D4Science, and the enabling technology, the software that we use, is named GCube. So in this short seminar, I will present, the three basic, characteristics of the initiative, of the operational platform, and of the software system. So let me start with the initiative. iMarine was an initiative that born in 2010 with a group of agency and research institutions that decided, to create this initiative. And in November 2011, it officially started, with the contribution of the European Commission through an integrated project. So, and starting from November, this project created and is currently operating this data infrastructure to support the principle of the ecosystem approach to fishery management and conservation of marine living resources. The project will last since September 2014, but there is already an agreement, to continue the operation of the data infrastructure at least, till April 2016. This project is mainly about, managing, integrating, agencies and European institutions, research institutions, and worldwide research institutions, from 4 different domains. So from the ocean environment, from fisheries, from biodiversity, and from the taxonomy institutes. And data providers. You may recognize, some of the acronyms that are in this picture. is not my intention, to present it. There are only to show that there are several interactions from different kind of agencies and institutes that usually do not work together. And the idea was, to enable, their cooperation through this different science infrastructure and through the exploitation of a number of standards for the data exchange and access. And the enabling technology, to support this was selected in G-Cube. The initiative is led by the iMarine board. On the right side of the slide, you see, the core members of the iMarine board. And then there are also other institutions that participate to the board without voting rights as observers. The idea of this board is, to clearly guide, the entire, the vision and the program of the initiative, and to supersede, the implementation of two main business cases. One is for the implementation of the European Common Fishery Policy, and the second one is to support the FAO, the Food and Agriculture Organization program on deep seas fisheries. And they develop also a governance model and during the project, and this governance model is the one that will allow us, to continue at least until, till April 2016. They also lead the identification of policies for data sharing and for software sharing across the different institutions. Then, I will briefly introduce the infrastructure. Clearly, I'm a computer scientist, so this is more about my activity in this initiative. And I will start, with clarifying what, is intended for the infrastructures. So infrastructure is a platform enabling researchers in different locations across the world to collaborate. And across the boundaries, across the locations, across, the different technologies. And then there are several characterizations of an infrastructure. One is a data infrastructure that is mainly about promotion and of data sharing and consumption. And then there is another one that is a computational infrastructure that is mainly identify mainly infrastructure where big amount of computational resources are offered to process large data sets. In any case, an infrastructure is mainly a platform where users can exploit those resources. And even if it is big, it's intended to be just one infrastructure across one administrative domain, and managing a common set of policies. In case of different science, instead, we talk more about an hybrid data infrastructure, because it combines over 500 software components that are not centralized in a single location and are not managed by using the same access policy or the same service level agreement. It's more a federation of different infrastructures that all together contribute to the satisfaction of the user requirement. Clearly, from the user point of view, when they access the for science, they cannot recognize that the resources can be provided by a commercial cloud provider, for example, or by another data infrastructure. So virtually, it appears as a single infrastructure, but it's a bit more complex than this. And everything, in iMarine was born from the user needs. So in this slide, in the next two slides, I collected, some of the requirements that were collected at the beginning of the project. And these requirements were, formulated by different types of users. So from managers that, they were looking for solution to preserve the data, to backup, to or a solution to securely deliver their data to well-known set of group of people, and or for from data managers that instead had the needs, and they were looking for solution for managing the full data life cycle, including all steps of the life cycle, so from import, validation, curation, normalization, publication. And their aim was mainly to reduce the cost of data maintenance, for their department or agency. And then there were the needs of the users that instead scientists and researchers that were looking mainly for way to access data across the different domains, or to process this data, to mesh up data from different domains, to analyze big data sets, or to perform validations. And so all these needs were considered at the beginning, and they were not considered as isolated needs of different kind of users. They were not considered disconnected. And for sure, looking at all of them, in an integrated way was not trivial. And the solution delivered by iMarine is an actual solution that satisfies the needs of the users, that contributed at the beginning of the initiative, but it's also a solution that has an outlook on the future, and in fact, during these 3 years now, we were satisfying, more users that were not present at the beginning, and now the iMarine data infrastructure is exploited, by also a bigger community with compared, with the one that was expected at the beginning. So it was designed for individual needs, to satisfy individuals, the needs of individual, research center or agency. However, the solution proved, to be able to satisfy the needs of the larger community that is behind, these 3 different domains, biodiversity, the statistical community, and the geospatial one. And I mean, technically speaking, so D4Science is geographically distributed in several sites. It's a computing infrastructure that uses resources across the administrative boundaries and across private and commercial providers. This means, that computational resources in D4Science are provided by research centers like, the National Research Center in Italy, or by commercial provider, big company in Italy like engineering, or also cloud computing provider like the Microsoft Azure cloud platform, for example. In terms of service, D4Science offer all the services that are needed, to manage properly an infrastructure. So services for allocation of the resources, for deployment, for monitoring and operation. It has a well-defined, service level agreement, and it clearly specifies, the way data are covered by, are protected, and there is a clear governance model, a privacy and attribution model, and everything that works, in this trusted network that is a virtual trusted network across, the different resource providers that are currently, contributing to D4Science. In terms of key characteristics, you may notice in this list that are, some of them are typical of a cloud infrastructure. So it offers, computational environments dealing with the volume of the data, and it offers an elastic management of those resources in such a way that resources can be assigned, to group of people only when those resources are needed. However, there are some specific characteristics that are not so common in other cloud computing infrastructure. First of all, it offers a collaborative environment to support scientific communities. It offers a rich portfolio of applications to perform access validation, enriching, processing, sharing, and mashup of data. And then it is equipped with a large set of storage technologies. So looking, in some details, in these key characteristics, first of all, it offers storage as a service to host and maintain data, and including, the standard relational databases, but also most of the available cloud storage technologies that may be needed, by the community, and it offers also support for scalable geographical databases. So it is equipped, with a special, let me say, a special equipment, to manage geospatial data in a scalable way, and we know that this is quite an issue usually. In terms of computing as a service, it offers capabilities, that are characterized by the fact that they are scalable. There is an elastic assignment of resources, and the environment does not support only MapReduce, even if it supports MapReduce through a Hadoop technology, but it supports also throughput computing, and in particular, to satisfy the needs of this community, support also parallel R. And R is, a framework that is widely used, by the biodiversity community. And then it supports a number of applications for the generation of metadata in the 3 different domains, in the geospatial, biodiversity, statistical, in such a way that they are compliant with standard, and for geospatial data with the DSPIRE directive. Tools for harmonization that include, disambiguation, validation, and integrity and consistency check, and for data exchange according to the different protocols. So it supports, all the OGC protocols, and then SDMX for statistical data, and the export in Darwin Core and Darwin Core Archive for the biodiversity data. In terms of the application catalogs, as I told you, there are more than 500 software components, hundreds of different web services. So the offer, we decided, to bundle, to group all this technology in 4 thematic bundles. One is for the management and interpretation of biological and ecological data, and this is called, BioCube. Then StatsCube is for the management of the statistical data, including, the complete full life cycle for the management of the data. Geocube is for the management of geospatial information. It includes also web processing service capability. And then finally, ConnectCube is a set of technology that supports, sharing of data, reporting, and aggregation and projection. In details, I put some references in this slide with the type of framework that belongs, to the different bundle, and there are framework for managing, observational data, taxonomy data, code list and control of the vocabulary, or tabular data, and so on. Just for your reference, in the slide. However, it is not only iMarine is not only a computational infrastructure, and it does not only offer a set of technology, it offers also access to a huge set of data sets. And so this does not offer only validation, enriching, processing, and sharing of data. And you see here a number of acronyms that you may recognize, like, OBIS is the Ocean Biogeographic Information System, WORMS is the World Register of Marine Species, GBIF is the Global Biodiversity Information Facilities, and then there is Catalog Life, but also, data access, made accessible through MyOcean or the World Ocean Atlas and so on. The complexity here, making all this accessible in a common infrastructure was, to manage the different policies that, the different data providers, have defined. And in order to do it, a number of procedures were implemented, were documented through guidelines, and all these data are made accessible through standards. So, I mean, the data sets that are accessible are, huge. So here you see some examples or a subset, of the data that are accessible across the, the different domain, starting from the ontology and the data warehouses that are accessible, and then biological and ecological data, geospatial data, statistical data, and then documents, reports, and textual documents. So, and everything here is accessible again, only through standard protocols and standard metadata description. So, however, I mean, this set of capabilities that I presented was not considered enough. So, the idea of creating this ecosystem of participatory data infrastructure that is regulated by policy and enabled by standard, and that is not only about accessing the data but also processing and sharing and supporting, mashup of heterogeneous data was not enough, because the idea was, to put the user or the group of users, at the center of this infrastructure in such a way that each user or each group of users, could customize the infrastructure according, to the specific needs, his own needs. So for this reason, it was integrated the virtual research environment framework provided by the GCube enabling technology, and this framework allows the creation of custom environment, dedicated environment, where it is possible to identify subset of data, services, and also computational storage resources, and everything is assigned, to a subset of users for a limited time frame, and with the policy identified by the community manager. And what is more important, that this is possible and is affordable because there are no additional costs for the providers of the resources, so of the participatory data infrastructures. And this allows to share and to collaborate. Sharing here is not only sharing of files, but it's also possible to share the workflow. It's possible to share, portion of data, for example, tables that are, in databases, or it's possible to share the execution of an algorithm, of a model, and I mean, everything that is a resource, the user can share it, and then it's possible to communicate and to organize, the content and the communication in a secure and policy-oriented environment. So to support the communication, we create an environment very similar, or that is very familiar to the end users, that looks like, any other social communication tool, like also Facebook or LinkedIn, or all these environment. So where there is a single place, to manage the communication. The difference is that here the communication is not only limited to feed from users, but there are also feeds from applications, and so it's possible to receive feeds when a computation is completed, when a new data set has been published, when a new model has been added to the virtual research environment, when all the different applications made available something. And there is also one place to manage and share data, but again share resources. But again, here are not only files, but it's possible to share files clearly, as in Dropbox, for example, but it's possible also to share you know, in the same way, a workflow, an experiment that I'm executing, you know, the parameter of my specific algorithm that I'm running, and I can share, you know, with my colleagues, for example. Just one word about, you know, the software, just one slide, and then I will give, you know, Gianpaolo will continue the presentation. As I told you, the entire infrastructure is powered by G-Cube. G-Cube clearly is not the only software that runs, but it's mainly the enabling software. It is an open source project released under the European Union public license. You see here some statistics taken from OpenHub. OpenHub is a service that ranks open source projects. In this slide, you see, you know, some statistics. It was born G-Cube in 2008, and starting from then, it continued to grow. Now it comes more than 10 million lines of code. It's a well-established and mature code base. But what is more important, that is, there is an increasing year-to-year commits with an increasing number of contributors every month or every year. And so this makes sustainable this large platform and make possible, you know, to rely an entire infrastructure on it. Now, there are a few examples of the analytics capabilities of the iMarine, and so I will leave the floor to Gianpaolo.
Well, hello. Okay, let me continue the presentation by Pasquale. And here are some examples of practical usages that our users in different community or practice have experienced, and some of them are collaborative and have been collaborative. Some other mainly pointed to give our users more efficiency about their own developed models. So I will give you some practical examples. We have basically divided the examples into 4 categories that mainly will talk about various functionalities that we host in the infrastructure, or that we currently host because we integrated the procedures and the methods developed by our community or practice. So the first set of facilities is the geospatial, regards geospatial analysis, and in particular we host very basic features, functionalities to rasterize maps, so that if you have a polygonal map reproducing the species possible presence in the ocean, we can transform, our methods can transform this polygonal map into a point map, so basically rasterizing the map. So on top of this, we have built several other facilities. One, for example, that is able to perform maps comparison. So if you have 2 very different maps, one on the right side is a raster map and one on the left side is a polygonal map, one of our algorithms can perform this comparison in order to give you an overall, similarity assessment between these 2 maps. So in this case you see directly that the algorithm assesses that the similarity is fair. So going next, the same is for signal processing applied to geospatial data, because we can apply several methods to extract the time trend, the trend in time of a certain environmental parameter like temperature, and by means of Fourier analysis we can extract the hidden periodicity in the signal. The same is for non-uniformly sampled signals, like the reports of earthquakes, in which we have facilities to resample the signal and then to retrace the spectrogram in order to detect the hidden periodicity, the hidden periodic phenomena in this signal. Another facility is able to extract information on about the water column. So if you fix the time instant and one point in latitude and longitude, we can retrieve all the information about a certain environmental feature along the water column. For what regards ecology, and we mean the interaction between species and the abiotic conditions of their living environments, we host several facilities. The first ones are to perform niche modeling, and in particular we host several methods belonging to the Aquamaps approach. In this case you see an image reporting the suitable habitat for the Atlantic cod. And there are several alternatives to produce this kind of models. And this is what is called niche modeling. So for what regards outliers detection, basically we have, if you have presence points for a certain species, we have facilities to search for these presence points in from several repositories of occurrence records for species, and we basically can automatically detect outliers by using clustering analysis that can be based either on the density of the points or on their distance. These are alternative methods, the ones you see here. For what regards biodiversity, I'm going to show you several examples that come out from a very tight collaboration with our community of practices. So this is not only about computer science, but also about integrating users and expert experience into our systems. So the first example is this, in which we report some sort of climate changes effect on species distribution. On the left side you see the trend of the overall occupancy for a set of more than 11,000 species over 20 years. So you see depicted the overall occupancy by this species in time, also estimated up to 2036. And on the other side, on this right part, you see instead that the analysis can focus on one single species and can report the estimated trends for several FAO area. So in this you see that the species is going to increase, and this in this other chart you see that the species is likely to be the species presence is likely to be oscillating. So we can also calculate the similarity between two habitats for a certain species. So if you have two habitats described in terms of a set of environmental features, this habitat representativeness score is a model that we host in the infrastructure that has been applied also to produce some papers in order to detect the similarities between two habitats in which you know that one certain species can live. In this case, we focused on the coelacanth. For what regards the processing of occurrence records, so presence points for certain species, we host several algebraic operations that are able to intersect or merge two occurrence data sets. And these algebraic operations are made on the top of spatial considerations, so in terms of longitude and latitude, as well as on distance in time between two observations, and also on lexicographic distances between some metadata like authorship and the scientific name of the species. Going forward, another tool that has been developed in collaboration with some biologists acting in iMarine is Bionym. Bionym is a workflow that basically is a cascade of expert systems, each one integrating a certain kind of expert knowledge about taxonomic name search. So if you have one string that you want to understand, one string referring to a scientific name of a species, you can check for the correct transcription. You can retrieve the correct transcription of this scientific name by looking at the records inside some reference sources. And each of these matchers that you see here incorporate expert knowledge that performs one different kind of search into these reference sources. In collaboration with UNESCO, instead, we developed this Trendylizer application. Trendylizer is a standalone application running on the infrastructure that is able to produce trends for species presence in the oceans and also for changes in the biodiversity configuration of certain areas. Indeed, we also have included some data analysis and data mining procedures in order to account for the usual sampling biases that are very common in a large repository for species presence points. One final point regards life history traits. So in this case, we face some laws in the nature. We address laws in the nature and modeling these nature laws by using data mining and statistical modeling facilities. Life history traits is a trend of iMarine that on one side tries to incorporate expert knowledge about species growth, species evolution also. And on the other side, we also contribute with new models by our side. And here are some practical examples. The first is about length weights relationship estimation for more than 14,000 species. In this case, we calculated these A and B parameters that link the weight and the length of a species for a certain number of species. And we, in this case, the model came from the GeoMar Institute that is located in Kiel and contributes to iMarine as a stakeholder. And in this case, the model came from them, and we incorporated their R scripts, ran them, executed them in parallel fashion, and the result was that they gained a time reduction with respect to their usual execution went from 20 days to 11 hours. So they had a very big reduction using, and a very practical benefit using iMarine in this case. More collaborative approaches were applied in this case in which the scientists wanted to estimate this trend for a set of stocks of commercial interest, and in this case we applied some of our Bayesian models, the models that we yet host in the infrastructure, in order to combine expert knowledge with the real data and to estimate this the health status of these 50 stocks. The last example that is still ongoing but is more collaborative indeed regards the calculation of the resilience and productivity pair, the best resilience and productivity values for a certain species. And this is, in this case, we used Monte Carlo methods and Markov chains models that are currently hosted by the statistical features of the infrastructure in order to filter out points, suitability points, pairs for a certain species. So this is a practical application that tries to estimate the maximum sustainable yield for certain stocks. So after this rapid showreel, we want to focus on the exploitation of our models, because the infrastructure, also the showreel, shows that the infrastructure can be exploited at several levels. So one is at the infrastructure level. So for communities that want to host their data or to exploit the sharing facilities that Pasquale has talked about, and they want to use our security monitoring facilities, so they want to become part of the infrastructure by contributing also with data, for example. Otherwise, they could use the software that we host in infrastructure, and I mean applications that are ready to use for our stakeholders, as well as models that can be employed in other experiments. And finally, they could use the infrastructure as a platform, development platform, if they want to contribute in terms of software to enrich the infrastructure, or they want to contribute with new services that could exploit the other the resources that are yet hosted by the infrastructure, so that they want to enrich the infrastructure with new services and facilities. So this regards more development framework to contribute to the infrastructure. So these are some links to the infrastructure if you want to learn more. So I could try to give you a very rapid example of an interaction with the infrastructure. So if you okay, if you can see, if you can still see my screen.
Yes, we're still seeing your screen.
Okay. This is the iMarine gateway, in which you can find several virtual research environments, each one collecting one different subset of our community. One of these is the Biodiversity Lab that we also use for our training classes. Among these, you have the processing tools that hosts many of our facilities for data processing. And for example, here you have the list of the algorithms that we host that are categorized. So for example, you can have details about data clustering facilities. This is the interface for to set up the experiment, to feed the experiment with input parameters and to execute the experiment. The interface is self-maintained because it is automatically generated by reading the input and the outputs of the algorithms. In this part, you can explore the yet produced computation and also retrieve the summary of the parameters that were used for this computation, parameters that you can also share with other people, and because this system also aims to reproduce the experiments, so to make experiments be reproduced also by other colleagues. so that you can share data sets as well as the parameters of the experiment. Indeed, there is this data space facility that basically clusters and collects all the data sets that have been produced by the algorithms or that have been imported on the platform by the user. So there is a rich set of tutorials to use this facility that you can discover through the iMarine portal. So there is the importing facility to, for example, import files, import new data sets, and this icon allows users to share or to visualize the contents of a certain data set. Some other facilities allow people to retrieve occurrence records for species. For example, in this case, I can search for the white shark occurrences, and after a while, will retrieve some data sets containing occurrence records. Otherwise, here we have the Trendializer system that was developed in collaboration with UNESCO, I was talking about previously, and otherwise facilities to explore the data, the geospatial data that we host in the infrastructure. So we have this interactive map to explore the maps that have been produced maybe by means of a certain model, through the processing tools. So this is a very rapid show of our capability, and so now we are open to questions.
Okay, wonderful. And just to remind everyone how to send questions, you can type them into the question panel of the user interface, or you can raise your virtual hand and I'll unmute you. This option only works if you have a working microphone or if you're on the phone, if you've entered your PIN number. So let's see. The first question, what does it cost to develop the existing infrastructure, and also what does it cost to maintain it?
What is the cost of maintenance? So, as I told you, iMarine is exploiting different science, and the idea is to make economy of scale. So, since the same infrastructure is also exploited by other initiatives and projects. Clearly, everything respect to the privacy and control of access and so on. So and there is this this way we are making an economy of scale at the level of exploitation of the resources. And the same is for the software, since it is an open source community developing the software, and so there are many organizations that are contributing to it, not necessarily belonging to iMarine, but belonging also to other organizations, other projects, and so on. Then if you are looking for the exact numbers in terms of euros or dollars and so on, there is a document that evaluates the cost assessment of the operation of iMarine. However, I don't know if it is yet public or if it will become public soon in terms of operation. I don't know if in some way I answered your question.
Okay. Well,
I mean, everything was done, sorry if I interrupt you, everything was done, to make, the operation of a large infrastructure sustainable and affordable. So there was a lot of effort spent, in reducing the cost of operation. So I can tell you, for example, for the operation of the for science, that is, quite large in terms of computational resources and storage that we provide access to. There is only one full-time employee, and this is, very low compared, to similar infrastructure operated by other organizations. And the same was for the operation of the applications and so on.
Okay, well, if that's the way you're able to quantify it, then that is helpful. Okay, and let's see. This is both a comment and a question. The participant says, I'm flagging an observation, and then a question to the presenters. It seems that the social sciences are missing from the data. Exploitation of fisheries is connected to the economy and society in terms of food and diet, global trade, and policy instruments that govern people for conservation objectives. Are there any plans to include the social sciences data and analysis?
Yes, sorry. Well, this effort is quite complicated to manage because you know that communities are made up of several actors, each one having its own policy, and each one pushing in one direction on the other. So we support scientists, indeed, and we support also their discussion. So first of all, we are experimenting more in data mining in the direction of life history traits, because much of that work goes into the direction of estimating the maximum sustainable yield. So to try to understand if the current situation, the current health status of some stocks, large stocks of commercial interest, is compatible with the kind of fishing activity they are doing. So we carry on the analysis, and then the analysis is discussed or rejected by some of our partners. But essentially, the platform is open also to this kind of activity, and is currently supporting that.
Okay.
I don't know if I have answered to your question.
I think so. Thank you, Gianpaolo. And if the questioner wants to ask a follow-up, feel free to write it in. Okay, so let's see. There was a question, how does the iMarine registry access the data systems that it brings together, such as OBIS and GBIF? Does iMarine maintain a copy or a cache of the data, or does it access it on demand from the sources?
Pasquale speaking now. So it's not always possible to maintain a copy of the data. This is not possible, for example, for OBIS, according to the OBIS policy. So we access on demand most of the data sets that are included, that are reported in the slides. When possible, because it's supported, by their policy, we have a cache. We create a cache on demand, with a different lifetime. And in other cases, we host, also the databases, their database, an exact copy of the database. So mainly depends not on the technology, because we support all cases, from hosting, accessing, or caching, the data, but, by the policy of the different data providers.
Okay, that's great. That's very helpful. Thank you. And let's see, another question. So for a user group with no previous experience with this infrastructure or connection with iMarine, but lots of data, what would be the process for making use of this? Setting up your own node, becoming a partner, something else?
Sorry, there was some noise on the line, so I missed the initial part of your question.
Yes, okay. So for a user group with no previous experience with this infrastructure and no connection with iMarine, but a user group that has a lot of data, what would be the process for making use of iMarine?
Yes. So on the last slide, I put also an email address, to showing again. This is to send a request to our communication manager, for this kind of requests. So there are several ways, to join iMarine. An organization or a group of users may request access, to become observer or core member of the iMarine board. In this case, their participation is intended, to collaborate to the identification of standard for data sharing, for policy definition and so on. So to have, a vote in the iMarine board that, as I told you, leads this initiative, or otherwise it's possible instead, to join the infrastructure and no technical requirements, no technical constraints are, really present. So it's possible to create a virtual research environment, and so to access one of the capabilities of the infrastructure, or it's possible to host, to manage an entire community. And so on the iMarine website that is accessible at the first link, there are all options, described, all the different ways possible to exploit infrastructure as a single user, as a group of users, as a community, or as an organization wishing, to join the board.
Okay, wonderful.
Just, sorry, another comment, maybe it's obviously. I mean, the exploitation of the resources is currently guaranteed for free, so there is no fee to pay. In almost all the cases that we support are the different organizations that are supporting the communities.
Okay, thank you, Gianpaolo.
Okay.
Let's see, and another question, how well are invertebrates incorporated into the BioCube database? For example, sea life base is far behind fish base in overall inclusion.
Well, indeed we are currently hosting the official version of fish base and sea life base, so we have the official copy of these two repositories directly hosted in the infrastructure. So basically, when you access to fish base or sea life base, most probably you are accessing our databases. So we have a very tight connection with them.
Okay. So I think the answer to the user's comment is invertebrates are incorporated to the extent that they are incorporated, like to the extent that they're covered in sea life base. Okay.
Yes. Yes.
And we have one last question right now. Can you describe how data quality attributes are used to help mash up sets defensively?
Well, what do you mean for data quality in this case?
And I'm not sure. So actually, Tom, if you want to write in any clarifications for this question.
Because we manage data quality at several stages, because every subgroup and sub community in iMarine has its own requirements for data quality. For example, FAO has the need to assess catch statistics with respect to official lists that are called code lists and are hosted by FAO. So data must be checked against that references. On the other side, for biodiversity data, we have that BioNIM facility, the one that I've told I've shown previously, that basically allows users to check their name. So it is more oriented to checklists and taxa names, reconciliation. If you want to check with respect to a reference repository, to a reference taxonomy, if your scientific name is correct or if it is an accepted name. So, and this is another aspect of data quality that we manage. And for each of these aspects, we host one solution in this case. I don't know to which you were referring.
Okay, and actually the person who sent in that question said this is very helpful, the information you've provided. So thank you very much, Gianpaolo.
So I think there is a question, because there is a hand raised, and also Pasquale wants to add something.
I forget to say before, to add, one of the questions before, that in order to also help, in the sustainable exploitation of food, we made, iMarine made, a mobile app, a mobile application named Applyfish that you can download from, for iPhone and Android. And for any commercial fish, it reports, important information also in terms of their resilience and their classification according, to the IOTC red list that, reports if the species is in danger, if it is, in danger of I don't remember the term. Okay, or so this the intention, through Applyfish was, to make more, to disseminate more knowledge about, the fisheries, and so to simplify the access to this information that otherwise is a bit complex to digest for a normal user, not for an expert. Okay. So if you wish, you can also, download, this Applyfish.
Okay, thank you, Pasquale. Oscar then typed in his question, and it sounds like it may be something that would be best if he gets in touch with you about. It's about Chilean fisheries data, and so Oscar, I'd encourage you to get in touch with Pasquale and Gianpaolo offline. We got 3 more questions in the last few minutes. Do you have a few more minutes, and we could do at least a couple of those? If not, if you need to go, then okay.
Yes, we can.
Okay. Another question that came in: are there any plans to incorporate ecological classification or models beyond the habitat niche modeling?
Yes, sure. We are now incorporating ecological models as far as they come from the community. So in the context of iMarine, we have mainly dealt with niche modeling, but we also consider clustering and also anomalies detection in occurrence records reporting as anomalies and as models. So we make them, we consider them part of ecological modeling. And there is a large part on which I went fast that is behind that trendializer system that I've shown, that regards the definition of common species, because you know that there is no analytical definition for a species to be common in a certain area. And this is another model that we have developed and that currently UNESCO is exploiting in OBIS. So we are collecting all these kind of models, and so we implement them, or we reuse the models that we currently host, as far as we have the requests coming from specific requests coming from our community of practice.
Okay, thank you, Gianpaolo. Let's see, and a question. Is there any standard data structure implemented in the system, for instance, to share data between two modeling platforms?
Well, it depends on the application, because generally speaking we have a common file system, let me say, that we call the workspace. It acts as a common file system that every user accessing to iMarine is endowed with. So if you register to the iMarine portal, everyone can register to the iMarine portal, then you will have this workspace area. The workspace area is used by all the application to store data. For example, tables are stored on the workspace in the format of CSV files, and once you have uploaded from your local system or from an application a dataset onto the workspace, you can share this dataset with other people, so that we currently use this common file system to share general purpose data. Otherwise, applications can share very specific formats for some datasets. For example, datasets regarding occurrence records are usually exchanged in under Darwin Core format. So we strongly encourage our users and the developers to use standards as far as possible. For what regards geospatial data, we only rely on OGC standards. That means that every layer is exposed in WMS format, WFS, or in other OGC standard formats. And we are going and we are pushing on being compliant also with INSPIRE specifications for metadata regarding this geospatial data.
Okay, thank you again.
And for statistical data, we strongly use the SDMX. That is very useful and quite largely used format for statistical data exchange. Yes? Are you there?
Oh, sorry, I was on mute. Thank you so much. Thank you, Gianpaolo. And one last question. Is it possible to integrate new software tools in the iMarine software infrastructure? I saw it has an R statistics software environment. Is it possible on request to add new R packages? Also, a number of scientists use not only R but also Python as a scientific software environment. Are there any plans to integrate software like IPython Notebook into iMarine?
So, well, there are two. I think this question is can be divided into parts. One is for integrating software coming from R scripts, for example, coming from users. So we currently have web interfaces with R integrated development environments that a user can use. So at first instance, if someone wants to introduce his code into iMarine, and if he wants our services to exploit his code, then he can use our integrated development environments for R. And once the application, and if the application runs on that environment that is based on RStudio, that is largely a largely used development environment, then we are certain that the code will run on our system. Furthermore, the system is flexible enough to accommodate for some very hard problems regarding related to scripting software, scripting languages. That is the dependency on the operating system and the dependency on the version of the interpreter to use, for example. And our system is going towards the the scenario in which it selects the most suited environment for to execute the script. So it will select the most suited machine and also interpreter to execute the R script. For what regards other kind of languages, well, the computing platform is Linux based. So if you have a compiled program, it can run on these machines because the machines have the option to run compiled programs as they were external programs. So they use the sandbox approach in which software is copied into these sandboxes and executed locally. So this prevents software to do damages to the system, possibly, but it also enables compiled programs to be run as they were external programs. So it is a bit difficult to completely answer to this question in terms of words, but we have almost published the paper on the way in which our platform deals with this problem.
Okay. Thank you so much. No, that was very helpful. And thank you both. We'll wrap up now. Thank you so much for a great presentation and for answering quite a few questions. And I think other people will be in touch with you after the webinar with probably more specific questions for their circumstances. We really appreciate you doing this, and thank you to everyone who was able to participate and even stay a few minutes after for the rest of the questions. I hope everyone has a wonderful afternoon, evening, morning, depending on where you are, and thank you again for participating in the webinar.
Thank you again. Thank you all for your participation.
Okay. All right. Bye, everyone.
Bye-bye.